Hi everyone, my name is Mariana Lendl and I am a trainer and technical documentation developer at In-House Solutions, the Canadian Mastercam reseller. In this video, I'm going to present the two feature-based machining strategies available in Mastercam, FBM Mill and FBM Drill. Mastercam's feature-based machining, known also as FBM, allows you to program a solid part faster by eliminating the process involved in identifying the solid features for milling and for drilling operations. Solid features describe the solid part's physical properties, such as its faces, the shape, size, location of holes, slots, pockets, bosses, and other characteristics. Feature-based machining analyzes the part for specific features and automatically creates the individual toolpaths needed to machine them. As mentioned before, Mastercam has two feature-based machining strategies, FBM Mill and FBM Drill. FBM Mill analyzes a solid part, detects all machining features in a specified plane, and automatically generates all the 2D milling toolpaths necessary to completely machine the solid. It machines closed, open, nested, and through pockets with both vertical and taper walls. For complex nested pockets, Mastercam creates a separate zone for each depth and creates the boundaries required to machine it. Using a common set of parameters, FBM Mill creates the following types of 2D toolpaths. Facing, if the stock in the Z-axis is above the top of the part. This could be optional. Each identified feature on the solid can be machined using roughing and rest milling with 2D high-speed area mill. Separate finished toolpaths for walls and floors can be created optional. And for this, pocket toolpath can be used with only the finish section turned on. Contour can be used for pocket features selected for slot cutting. Helix bore or circle mill for round hole features selected for hole milling. Outside contours, if the stock extends beyond the part in the X and Y axis, is optional. You can see an example of how Mastercam FBM Mill generates the toolpaths. FBM Drill automatically detects holes in a solid based on your specified criteria and generates a complete series of drilling and chamfering operations for the detected features. It also can generate circle mill or helix bore operations for large hole features when you activate the hole milling page and settings. This is an example of how Mastercam FBM Drill generates the toolpaths. To demonstrate Mastercam FBM Mill and FBM Drill strategies, I'm going to machine a die shoe part. I will be starting with the FBM milling and set the parameters to face the part, machine all the pockets, and circle mill the larger holes. Time to move to Mastercam. Couple of things that I need to mention before starting programming this complex part. The solid part originally was just a solid body without any history. I have used model prep and find holes to instruct Mastercam to find all the holes. I renamed them based on the hole finish type. As you could see, all the 3/8 diameter holes will be reamed with a 3/8 reamer. The 15-32 diameter holes will be tapped with a 1/2 inch 13 threads per inch tap, and the 0.201 inch diameter holes will be tapped with a 1/4 inch 12 threads per inch tap. I also prefer to select in advance the tools that I want to use to machine the part. Otherwise, Mastercam will automatically select them or create them as needed. To select the tools, I use Tool Manager. And as you could see, I already select the 6-inch face mill for facing, the 3/4 flattened mill for roughing, and the 3/8 flattened mill for finishing. In the tool manager, you can also edit each tool and set up the proper feeds and speeds. You can do a right mouse click on the tool that you want to edit, select edit tool, and in the finalize properties, you can set up the feed rates and the spindle speeds according to what you need. I'm not going to change them in my demonstration. There are way too many factors that affect how speeds and feeds should be chosen. Just to think of some tool size, shape, material, sharpness, part material, fixturing, and so on. I'm just going to close the tool manager and start to program the part. First step before you can start FBM milling, you will need to define the stock in the machine group stock setup. This is mandatory, otherwise the FBM mill will not work. So from the machine group, I'm selecting stock setup. I am going to use bounding box to define the stock. And I'm going to let Mastercam to select the solid for me. And I'm just going to add some extra stock in Z, 100 thou extra. The extra stock will be machined with the facing operation. To start the toolpath, from the toolpaths ribbon to the group, I'm going to expand the gallery and I'm going to select feature-based milling. In the setup page, I always make sure that automatic initial feature detection is enabled. I can also set the tools that I want to use to machine the part. And in our case, I'm just going to enable use tools in part file and disable the rest of the settings. The system will look at all the features that are in the top plane. And I also want to instruct Mastercam to finish the outside part, breaking through with an extra minus 0.05 inches. In the feature detection, I'm going to have through features enabled, and I'm going to give again an additional breakthrough 50 thou. And I also want to tell Mastercam to mill round features using hole milling. Mastercam will recognize all the holes greater than 1 inch and mill them using either circle mill or helix bore. I'm going to start to set all the tools that are going to be used to machine the part. I'm starting with the facing. I do a right mouse click, select tool from part file, and I'm selecting the face mill. In the roughing tools, I'm going to repeat the same procedure, and I'm going to select the 3/4 flattened mill. I'm not going to use a rest milling operation. The finish tool, the 3/8 flattened mill, can machine all the corners. In the cut parameters, I am going to set first the facing parameters. The only thing that I'm going to change here is the cutting method. I'm going to use zigzag cutting method, which is more appropriate for the shape of our part. Nothing else needs to be changed here. The default values will work perfect. In the roughing, I just make sure that climbing is enabled. And I want to set a step over in X and Y as a percentage of a tool diameter. In our case, percentage of the 3/4 flattened mill. And I'm going to change that to 50%. I'm going to use depth cuts, and I'm going to set them to 50% of the tool diameter. The entry method was already set up to helical entry. And we have stock to leave on walls only, set up to 20 thou. No rest milling, no floor finish. I'm just finishing the walls. And I'm going to set up the wall finish by number, just one pass, with an overlap of 2% of the tool diameter. Cutting method, it's already set up to climb, and I do have entry-exit moves already set up. The only thing that I'm changing here is the depth of cuts. Again, I'm just going to set them up to 50% of the tool diameter. For hole milling, I'm just going to enable circle mill. Of course, depending on how you want the chips to be removed, you can also select helix bore. I'm going to set up the circle mill parameters. Again, percentage of the tool diameter for the finish. And for the roughing, the same percentage of the tool diameter. I'm just going to increase the value to 50%. I want to use depth of cuts, so the same percentage of tool diameter. I want to keep the tool down. Entry-exit values are already set up. Nothing else that I need to worry here. Linking parameters. The clearance is set up to be measured from the stock model and is set up to 1 inch. Retract is going to be incremental 1 inch, and the feed plane 1/4 inch incremental. All the values are based on the stock model. In the additional settings, the coolant is already set up to flood. Of course, you can choose whatever settings you want to. I'm just going to generate the toolpath. It can take several seconds depending on the part complexity. You notice that the programming time was quite fast. We just needed to make few changes in the parameters. But with that said, the machinist experience is still needed to generate the toolpaths as you want. It's done. If you want to make any changes, you can go back into the feature-based milling parameters and just change whatever parameter you need to change. Otherwise, you can just check one operation at a time. You can see the facing, circle milling. There are lots of circle milling operations. And of course, you will see eventually the roughing of the pockets. With this 2D high-speed area mill, we are roughing the pocket at the first depth. And with the pocket standard, using only the finished section of it, we are finishing the walls. And then again, 2D area milling to machine this pocket. The finish walls follows. Then machining the pocket area that is cut through. And after the roughing, finishing it. And again, we are going back to some circle milling operations. If you scroll down, you can see that the outside profile has been machined with a counter operation. You can just continue to check one operation at a time and see what's been machined, or we can just select all of the operations and run verify. Once you select verify all selected operation button, The system will launch another window, and you can use Mastercam Simulator to check the toolpaths that were created with the FBM Mill. Lots of circle mill operation, as well as lots of roughing and finishing operations for the pockets. One thing before we exit verify, you can notice that the two pockets that are on the right side were not machined. I'm just going to minimize this, and you can see the two pockets. If I remove the toolpath display and just zoom in, those two pockets are 3D features, and the feature-based machining milling cannot machine them. In order to machine the two pockets, you will need to use a 3D toolpath. Just keep in mind that feature-based milling can only machine 2D features. I will continue with the FBM drilling and set the parameters to drill, tap, and ream the specified holes in the shoe die. As I mentioned before, the original part file had only a solid body and no history in the Solids Manager. To find all the hole features, I used model prep and find holes command. I also renamed the holes that had to be reamed and tapped. In the Toolpaths Manager, I'm going to collapse the FBM mill, and then I'm just going to move the insert arrow way below all the operations to ensure that the feature-based drilling is going to be at here. To start the FBM drill, I need to go into the Toolpaths ribbon and click on the Expand Gallery, and from the hole making, I'm going to select FBM Drill. First thing to do, setup, I need to make sure that automatic initial hole detection is turned on. I do not need to group the holes, but I can group them by plane, because you can create holes in different planes, and I can also group them by tool. I'm just going to leave it to none. In the sorting, I could choose different options for how I want the holes to be machined. I'm not going to select anything else. And next, we'll just go into the hole detection page. Everything is already set up for me. I want to include blind holes, I want to include chamfers, and I want to limit the search to the top plane. Mastercam is instructed to search for all the holes that are between the minimum diameter of 0.03125 inches and maximum diameter of 1 inch. I need to use spot drilling to chamfer the holes that are going to be tapped or reamed. And I'm going to use the 3/4 spot drill from the library for this. I can also change the maximum depth to, let's say, 1/4 inch. I need the drilling operations that are done before the tapping or reaming. And as you could see, pre-drill is enabled, and I'm only pre-drill pilot holes. I don't need to mill any holes. We already did circle milling for the larger holes that are bigger than 1 inch in diameter. And in the tools page, I'm just going to use tools from the library. I did not select the drills, the taps, and the reamers that I need to use for this specific part before, so I'm just going to let Mastercam to find the tools from the existing library. In our case, the existing library is Mill Inch tool library. In the linking parameters, I'm just going to leave the clearance set up to be measured from the solid height, 1 inch above it. And I'm going to use clearance only at the start and end of the operation. Between the rest of the holes, the tool is going to retract the retract level. I also want to make sure that I give an additional breakthrough for through holes. I'm just changing this to 50 thou. I also need to make sure that I have a tab rim adjustment. As you could see, the distance is already set up to 0.125. In the coolant, you can see the flood, it's already selected, but you can choose any other options that you want to. Most important thing next is to detect all the holes, and I'm just selecting the button that allows me to do that. And then in the features page, you will be able to see all the holes that the software can detect right now. You can see there are mostly drill type. There might be some counter bore, but most of them are drill. With that said, remember we want to ream the 3/8 holes. I'm going to click select the first drill. If I wanted all the 3/8 holes to be automatically selected, I can enable this button that says select common features. And to change the hole type, I just need to do a right mouse click. And from the hole type, I need to select ream. We need to make sure that the finish tool is also set up to reamer 3/8. I need to find the other holes that are 3/8. One thing that you should be able to see right now is with those arrows, the system shows you where the 3/8 are located. I'm doing again a right mouse click and change the hole type to ream. And pick the other holes that start at a different height. And again, I'm just going to enable ream for them too. Holding down the shift key, I'm going to select the rest of the 3/8 ream holes. And another right mouse click, make sure that the finish tool is set up to reamer 3/8. Next, I'm going to look for the 0.21 diameter holes that I want to change the hole type to be a tab right hand. As you could see, the 1/4 inch, 20 threads per inch right hand tab was allocated as the finish tool. I'm going to find all the holes that I want to tap. So again, I'm just selecting it and right mouse click, hole type, change to tab right hand. You can also check which ones are on the part. And then the other holes that I want to change are the 15/32 diameter holes. Let's see where they are. 15/32 diameter holes that I want to change the hole type to be again a tab right hand, which will make those 1/2 inch, 13 threads per inch tab holes. Need to make sure. Oh yeah, I have these ones too. I'm changing the hole type to tab right hand. I believe these are all of them. And now I can just generate the toolpath. Again, it's going to take several seconds until the toolpath will be generated. You can see that in the background. And now we have the feature-based machining drill. The parameters of that toolpaths are available if you need to make any changes. And then all the operations will be listed, and you can just check one at a time as we did prior with the feature-based milling. Or you can select all of them and run Mastercam Simulator. I'm just going to look right now to find tap holes and the ream holes. You could see the tap holes right here, the 1/4 inch and another 1/4 inch group of tap holes. These are the reamed holes. Again, more here. And we just need to find the 1/2 inch tap holes. I'm going to select all the operations, and let's run verify again. Roughing pass for the facing, followed by a finish pass. And then circle milling operations, pocketing operations. The order in which those are performed can be optimized. You can just move them in the Toolpaths Manager and reorder them as you want. The main advantage of the feature-based milling is that it takes a couple of minutes to set all the parameters, and you get the entire part machined without having to select each individual feature and set up a toolpath and set up the parameters for each of them. We can always speed up the process. Of course, the drilling operations. You can imagine it would have taken you a lot of time to machine one by one each feature. Peg drilling, tapping, everything is done automatically. As you can see, all the holes have been machined with the appropriate tools. These are some of the main advantages of the FBM milling and drilling. FBM eliminates the manual process involved in programming solid parts. You can set up the FBM operation defaults to be used on similar parts. Complex parts can be programmed in a very short time. Toolpaths created by FBM are standard Mastercam toolpaths, and users can modify them as needed. Machinists who are new to Mastercam can let FBM do the pocketing, contouring, and drilling of a solid model for them. Traditional CAM programming of a complex 2D part can take hours, especially if the part includes nested pockets and faces in different planes. Old programmers, new and experienced alike, benefit from the time saved with FBM.